Hey there, my name is Alejandro and welcome back for day 5 of me doing the NeetCode 150 series. So today's problem is for October 9th, 2024, and let's get straight into it. Okay, today we get a LeetCode easy problem 121, best time to buy and sell stock. You are given an array prices where prices of I is the price of a given stock of the ith day. You want to maximize your profit by choosing a single day to buy one stock and choose a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So let's look at an example. Prices is equal to 7, 1, 5, 3, 6, 4. The output is 5. Why? Buy on day 2, price is equal to 1. Okay. And sell on day 5, price is equal to 6. Profit equals 6 minus 1 is equal to 5. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. Okay, so essentially you get one transaction, you get to buy once and then on a specific day, and you're allowed to sell on a future day. Okay, cool. Okay, so this is a sliding window problem. Okay. So let's think about this. So you start off at 7 here, and you probably So you want to drop down. You don't want to buy the 7 and then buy the 1, right? You want to keep going until you get to a local minima, right? You want to keep looping until you get to a local minimum, right? Because otherwise, it does not. Well, okay, or until you get to the end of the array, right? Can you buy and sell on the same day? Return them. Okay, so you're given an array. You want to choose your profit by choosing a single day to buy and a different day in the future to sell that stock. Okay. Worst case, right? Worst case. So what's the length of the array? Price's length is equal to 1. So what do you do if the price's length is equal to 1? Right? What if I have one price? If I do prices of 7, right? And here I do return -1, right? Let's see what that does. Okay, so what was the expected output in this case? Profit of 0. Why? Okay. Oh, so here we have a decreasing array. In this case, oh, so you're allowed to not choose to do a transaction. Okay. So res we can initialize to be equal to 0 and always do a maximum of something, right? So okay, so core idea. So idea, keep moving onwards until reach a local maxima in prices. From that point on, only update okay. Also, I can start off my left pointer at the very beginning. Okay. So essentially, okay, we can do this in a bit cleaner of a way, right? Keep moving onwards until reach a local maximum prices. We don't even need to do an initial sweep, right? So essentially, it's like I can start my left pointer here, right? Ideally, it's like I buy at the lowest and sell at the highest, right? And the point is that okay, I'm going to loop through all the other indices, right? And it's like, okay, like 7 and 1, we're going to compare at -6. Between 0 and -6, 0 is bigger and so on, so we count this as our largest profit, right? Otherwise, we see here this is now a smaller stock price, right? So since it's smaller, we want to move on to it, right? So we want our lowest so far to be the lowest possible purchase price that we can make it, right? So at the very beginning, we'll initialize, a left pointer is equal to the very first element of prices, right? And then here, we can only consider past that price, right? So we cannot buy and sell on the same day, right? If we buy and sell on the same day, I guess that is how you get 0, right? So maybe that is how. Oh no, it just means in this case no transactions are. Again, it's a different day in the future, right? Oh yeah, return maximum. If you cannot achieve any profit, return 0. Okay. So that's why. Okay, so now we can just do for I in range 1 up to the length of prices, right? So if price is equal to prices of I, right? Then we're gonna do if price is smaller than the current price, which is equal to prices of L, then L is going to be equal to I, right? Or maybe to make this easier to understand, right? I'll just do prices of I, right? So if the current price, right, so prices of I, is smaller than the current price that we say like, hey, we can purchase a stock, then let's make our index L equal to I, right? Because this is a cheaper version of the stock price. So let's update to buy the cheaper version of the stock price, because at our current date, this is the cheapest that we've ever been able to get so far, right? So that way, for any single day, our pointer will currently point to the cheapest possible date that we can possibly buy a stock up to our current point, so up to our index I, right? And otherwise, essentially, we'll just compute the difference of res is equal to max of prices of L. So the purchase point, so however much you sell it for, so prices of I minus prices of L, right? Between res and this, right? Usually, so we could usually do this after update L afterwards, but if we don't, then we'll get a negative number instead, and we know to reject that and so on. This will just give us 0 instead and so on. So it's like we can also just do like an else clause, right? So I think that something like that will work. Otherwise, we don't need the else clause at all, right? For I in range, yeah, for now, let's comment this out, but we might be able to just put an else clause. Here I just need a thing. So for every price, right? So the point is like you go from 7, then you look at 1, right? And it's like, okay, yeah, the price is lower and so on. L is equal to this, right? And then it's like res is equal to max between res, which is 0, and then prices of I minus prices of L. Well, here we just updated L to this, so 1 minus 1 is equal to 0, right? Otherwise, we look at 5 here, right? And it's like, okay, well, our current L is equal to this 1, right? It's at index 1, but also with value of 1 in here. And so then we consider the next element, which is 5. This one is lower than 5, so we do not move our left pointer, and then we do like this price minus our current price of L, which is what we confirmed as our stock purchase, right? Because we want the minimum stock purchase price that we have seen so far. And so 5 minus 1 gets us 4, and then 3 minus 1 gets us 4, 6 minus 1 gets us 5, which is actually the best solution, 4 minus 1, so on. And then whenever we see a cheaper stock price, we update our index. Okay, so maybe instead of L, let's just do cheapest index, right? Right, so it's like, yeah, prices of I is cheaper, then update cheapest index. Otherwise, yeah, get the current price. And here we can just return res. So will something like this work? Okay, it does. And what if we put this in the else clause? I expect this to still work. Okay, so we can actually completely get rid of this idea. Okay, this is actually a very straightforward problem, right? So there we go. Okay, so let's run a solution here. Okay, 45%. Okay, so it seems like the whole crowd is inside this little region. Okay, we can try submitting again, see if we get like slower, faster, blah, blah, blah. 46%, okay. But the idea is essentially sliding window, right? So you can't get too much faster anyhow. Maybe I can do something like for price in prices. I can do price is less than that. Oh, but I need the index anyway. Whoops. Then we do this. Maybe we do price is equal to prices of I. You know, save on a tiny computation here, but not a meaningful one. It does nothing. Yeah, this is as efficient as it gets. It's just a no event solution and so on, which I remember was the optimal solution for sliding window and so on. It's just like, okay, we're getting dealt with all one stuff here and so on, but the idea is very much the same, right? Essentially, okay, as always, as I do in all my videos, I'll do a quick recap of how I was able to solve the problem. So essentially here, this is the problem is very straightforward. You're given a list of array prices, right? And you're allowed to make a single transaction where you purchase one of the price, well, these prices represent stock prices, right, of one specific stock, and like prices of I represents the stock price at the ith day. So essentially it's like, okay, you want to make the maximum profit, right? And in order to make the maximum profit, what do you need to do? You need to buy low and sell high, right? And so it's like, okay, up to the ith day, keep track of the cheapest found stock price so far. Then update your maximum profit to the larger between currently found maximum profit and today's stock price minus the, oh sorry, 1 second, okay, the cheapest stock price, today's stock price and the so yeah, minus the cheapest stock price found so far. So that's essentially the idea, right? So the idea is you want to buy low, sell high, and so it's essentially like you up to the ith day, right? So this is what this for loop represents. We're now at the ith day. We want to keep track of the cheapest stock found so far, right? So essentially it's like, okay, if the current day's price is smaller than the price of the cheapest, well, the cheapest price that we have seen so far. So we keep track of the index of the cheapest price that we have seen so far. Here, okay, we don't even need to do this, right? So we can just do a cheapest price, right? So, and then here, okay, maybe that's how people got it a little bit more efficient. So for price and prices, maybe we can do something like this, right? And here we can call this max profit. And so for price is equal to 0. If price is smaller than cheapest price, or if cheapest price is greater than price, then cheapest price is equal to price, right? Otherwise, max profit is equal to the max between max profit and price minus cheapest price, right? And then return res. So something like this should still work. Actually, here we need to return max profit, right? So something like this should still work, and that way we get rid of indices straight up. Whoops. Okay. It does not work. Oh, the cheapest price we have seen will be prices of 0. We'll just start off with that. There we go. And now let's go onwards. Okay, so 65%, but this is what I mean by, like, you know, fixing some O1 stuff and so on. But the idea is very straightforward, right? So essentially it's like up to the ith day, you keep track of the cheapest price you have absolutely found so far, right? So this cheapest price, we started off as the very first price in our prices array, right? And every single price that we go through, if we happen to see that there is the current price is cheaper than the currently found cheapest price, then we update cheapest price, right? And there's no need in updating the max profit, right? Because today's profit will have changed cheapest price to be price, right? Because that way we make it smaller. And then since cheapest price is the current day's price, then price minus the cheapest price is literally just 0, right? And 0 is the minimum value you can get, so it'll definitely be the smaller value here, right? We initialize to 0. So that's why I do the else clause and so on. But you definitely, you don't need the else clause. Otherwise, you know, if the current price is actually bigger than the cheapest price that we have found so far, then that means there is actually room for profit, right? And so we update our max profit to either be the max of our current max profit and whatever profit is to be gained from today's stock price, right? So it's like we keep track of the cheapest price that we've ever found for the stock up to today's date, and then the current day's price, we subtract the cheapest price found so far for the maximum profit I could have had within that window, right? And then it's just I keep doing that for every single day that the stock was available, and then at the very end return max profit. So that's essentially how I was able to solve that solution, and I hope that solution makes sense to understand. And yeah, that's pretty much it for this video. As always, for these NeetCode 150 problems, I just have to make sure I remember. We'll check off the box saying that I did it. So now we should be at 5 out of 28. Beautiful. We're right on track. We'll get these done in absolutely no time. And yeah, so that's pretty much it for today's video. If you did find it useful or enjoyable, I would highly appreciate if you left a like or a comment. And otherwise, I'll just catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.